Good afternoon, boys. Good afternoon, girls. How are you? How was your day? Today, this afternoon, we'll carry on with our mathematics lesson, and then we carry on with our statistics lesson. We started statistics lesson yesterday, and then today we'll be carrying on with it. Okay. Before I continue, my name is Abdul Jafar Abdullahi, and then our topic today is statistics. And then at the end of our lesson today, we should understand and apply important statistics terms such as scattered plots. You should be able to do a scattered plot. What is scattered plot? What do you mean by line of best fit? What is meant by line of best fit? You should be able to draw a line of best fit in the given scattered plot. Then regression equation. You'll be able to do the regression equation. Okay. The least square regression equation you should be able to do, and then you should be able to find the least square regression equation using our calculator. So using calculator to find the regression equation. Okay. Now we'll start off with scattered plot. So what is scatter plot? Scatter plots are useful diagram that enables researcher to compare two sets of data to determine whether there is a relationship between them. So we're saying scatter plot is a sort of diagram that is used to check if there's a relationship between two variables. Between two events or between two variables, you use scatter plot to see if there is a relationship between them. For example, relationship between smoking habit and the chance of getting lung cancer. I want to see if there any relationship between smoking habit. Smoking habit is a variable, and then chance of getting cancer is another variable. So is there any relation, is there any correlation, is there any relationship between these two variables? So with scatter plots, we can use scatter plot to determine if there's a relationship between these two variables. And then another example is the number of cars on the highway and the accident rate. So is there any relationship, is there any correlation between the number of cars on the highway and the rate of accidents? So these are two sets of variables. So we want to see if there any relationship between them, any correlation between them. So with scatter plots, we can use scatter plots to see if there's a relationship between these two set of variables. For example, talk about the learner's school fees and the income of the school. So the learner's school fees and income of the school is another example. So we can give as many examples as we want. So in research, we research this kind of situation. We try to find out if there any relationship between one event and the other. So and then to do such kind of research, what do you do? We go into data collection. We go and collect data on the two based on the two variables, and then plot the data, plot our record, our results, our records, and see if there's a relationship between these two variables we are considering. Okay, so plotting this data on data plot diagram will show trend in the data. So after collecting data, based on what we are investigating, for example, we are investigating the number of cars on the highway and the accident rates. So we collect data based on number of cars on the highway, and they collect data based on accident rate. So we plot these two on the scattered diagram, and then from there you can see if there's any trend in the data, if there's any relationship in the data, and then we can make our conclusion. So data could follow a linear, quadratic, or exponential trend. So data can follow linear, quadratic, or exponential trend. Okay, we have some data that are form a linear trend. Some data form a linear trend. We have some data that when you plot them, so we have stuff like this. So like this, it is a linear trend. It's a linear trend. More important, more specifically, is a directly proportional linear graph, meaning there is a relationship between the two variables plotted on the y-axis, one variable on the y-axis, one variable on the x-axis. So we are saying there's a relationship, there's a correlation between the variable, that variable is on the x-axis and that of the y-axis. And this relationship is was direct. meaning as one variable increase, the other one also increase. The same this kind of data shows a linear pattern, a linear relationship. So other kind of information we can have, and then can describe that can describe a quadratic pattern. You see a pattern going this form. So this is a quadratic pattern. So you can have a scatter plot showing data within a quadratic pattern. Okay, and they can also have other exponential pattern. So these are the type of scatter plot we can encounter in our statistics lesson. Okay. Now let's see, another thing we need to look at now is the line of best fit. The line of best fit. Consider the following scattered plots of information obtained by a publishing company that recorded the number of books sold over 12 months. Okay, so investigate the relationship between the two sets of data, the number of months and the number of books sold. So we want to investigate how does the number of months and number of schools, is there any relationship between the number of months and number of books sold? Is there any relationship between those two? Okay, the publisher is a publishing company, and then it records the number of books is sold over a period of 12 months. So is there any pattern, is there any relationship between the number of books that is sold and the number of months? So given that these are for the number of months, you have 1 to 12, and these are the number of books sold. Okay, so I want to see now, is there any correlation between the number of months and the number of books sold? So we're saying to see if there's any relationship. What do? We draw a scattered plot for this. We draw a scatter plot. We try to plot this. Try to plot these values on the x and the y axis. Okay, so the number of books sold would be dependent on the month. So we're going to have number of books sold on the vertical axis, and the month will be our independent, which will go to the x-axis. Remember, your independent variable is will go on your x-axis, and dependent variable will go on your y-axis. So you see, the number of books sold should depend on the month. So you see, the number of books sold will be our dependent variable, which should be on the y-axis, and the number of months will be independent variable, which will go to the x-axis. Okay. So if you plot that, you have number of books sold, and then the months. Okay. So if you plot that by month 1, the number of books sold was 10. By the month 2, the number of books sold was 20. By month 3, it goes to it reduces. It was 21, it reduces to 20, and in month 3 it comes to 38 there, and in month 5 it comes to 48, and the month 7 it goes to 49 there, and the 8. So when you plot the scatter plot, it goes this way. You see, so when after plotting you have something like this. So this is called a scattered plot. Okay, this is a scattered plot. Okay, now you can see the dots are all over the scatter, but if you give it a close examination, you see that there is a form of pattern. There's a form of pattern that slides that slopes upwards. So to now determine what the slope look like, or the pattern look like, is now to draw a line. To draw what we call a line of best fit. You need to get a line of best fit to be able to make some projections, to be able to make some extrapolations. For example, in the 13th, in the 20th month, how much book is being expected? How much book are we expecting to sell? So based on this result, up till the 12th month, so by the 15th month, can we based on this data, can we predict or can we extrapolate how many books are we expecting to sell? So to do that, to find the relationship between the number of books sold and the month, so we need to come up with an equation, a sort of line, a sort of pattern, a sort of equation. Okay, right. To do that, first we need to get a line of best fit. We need to get a line of best fit. So a line of best fit means what? A line that connects some of the points together. A line that connects some of the points together Okay, how do we determine if how do we determine that it is x and y axis? Okay, now we're saying again the x axis we always have independent variable. The x axis we always have independent variable. Why the y axis? You know, plot the y axis. We're going to plot the dependent variable on the y-axis. Again, always when we are giving two variables, one must be dependent, the other one will be independent. So the dependent one must go on the y, the independent variable must go on the x. So now the question is, how do we determine which one is dependent and which one is independent? So to do that, you need to look at the situation you are given. You need to look at the situation you have. For example, in this situation, now we have what number of books sold, number of months, and the number of books sold. We have to plot a graph of number of months and number of books sold. So one must go to the vertical axis, one must go to the horizontal. You think the dependent one must go to the dependent must go to the y-axis, the independent must go to the x-axis. So now, which one is dependent, which one is independent? So number of months and number of books. So it will make sense that number of books will depend on number of months. Maybe during the beginning of the year, you expect to sell more books. Okay, because now students will want to come to school, college students want to go to school, parents want to buy books for their children. So the number of books should depend on the months, not the months depending on the number of books. It doesn't make sense to say the month depends on the number of books. Okay, so the number of books should depend on the month and not the reverse, not the month depending on the number of books. So we say the number of books should depend on the month, meaning the number of books that be sold will depend on which of the months. Like December, people are busy with holidays, traveling everywhere. So you expect the sales of books to be less. So early January, you expect it to be more. Mid-June, you expect it to be more, but not like compared to the beginning. So the sales will vary based on the month. The sales of the book will vary based on the month we are. So now, so it makes sense to say that the number of books depends on the month. So if the number of books is a dependent variable because it depends on the month. The number of books will go to the y-axis, and then the number of months will be referred to as the independent, which will be plotted on the x-axis. I hope that is understood. So basically, to determine which one is dependent, which one is independent, it has to do with you giving it a close look. Giving it a close look. Usually we say what time is independent. Usually we say time is independent. So we say time is independent, that everything depends on time. So that's like a sort of general thing, but there's no proof of that. So month is a form of both time. So it's generally times are independent. Okay. Like we are looking at, for example, the temperature of the day and the time. The temperature of the day and time. The temperature of the day and time. Yeah. Okay. All right. I don't understand. Yeah. So yeah, but the bottom line is you just need to find out. You have to be careful to look at what is depending on what. I'm giving another example, like the time of the day and the temperature. So which one should depend on which? Will the temperature depend on the time of the day, or the time of the day will depend on the temperature? So you expect that what the temperature should depend on time of the day. In the afternoon, we expect it to be hot, and then in the evening, to expect and the moderate to cool. So the temperature will depend on the time of the day. So temperature will be dependent, which will be on the y-axis, and the time of the day will be independent, which will be on the x-axis. Okay. Now another example. Say we have like the income of the school and the school fees of the learners. The income a school makes and the school fees of the learners. Say a school is making income, so and the school, what is the relationship? Which one depends on which? The income a school make and the learner school fees. So which should depend on which? So looking at it carefully, you're going to see that what the income should depend on how many students the school have got. So when they have a lot of students, then they are expecting what more income. When they have a lot of students or when the school fees is high, then so the school fees, the income will depend on the school fees, or the school fees, the income will depend on the number of students. So you're going to say the income, again, we're looking at income made by the school and the number of students the school has. So which should depend on which? So we say what the income should depend on how many the number of students. We say the income is on should be plotted on the y-axis and number of students should be on the x-axis. So basically, what we say in SS is you need to give it a close look and see which depends on which. Give it a close look and then you can always determine. But when it comes to time, so time is always we say generally as is what independent. Okay, so time independent. I do think you understand that. You can ask more questions if you've got. Okay, so carry on now from there. So we're saying so to represent this information, we do that on a scatter plot to see if the relationship between best fit. Okay, so now how do we go about that? So our line of best fit will go like this. It should be a sort of line that will be drawn in such a way that it will be leaving some of the points on the left and some of the points on the right. So the line should pass through. It mustn't connect the whole of the points, but should be drawn in a way that it goes just in between, making sure that the number of points on the left equals the number of points on the right. We call that the line of best fit. Okay, it is clear from the above graph that the points do not lie in a perfect straight line. So it doesn't line, our scatter plot does not lie on a perfect straight line. The information on the graph does not follow a linear trend. It does follow a linear trend, but not a perfect straight line. But it's a linear trend. It's not a parabola, not a quadratic, and it's not exponential, as we did see. So it's a linear trend. So our scatter plot is showing a linear trend. It's increasing upwards, it's sloping upwards. Okay, now, so we are seeing we're going to draw a line that also slopes upwards. We can draw what is called a line of best fit, which will help us to predict future values. So with our line of best fit, we can use it to predict our future value. We can use it to get our other values that are not within the graph. For example, we want to find out how much sales will be made in the 20th month. Our month say by 12, you want to find out how much book is likely to be sold at the 20th month. So we use the line of best fit to predict that. In order to do this, draw a line through some of the points with the aim of having the same number of points above the line as below the line. So you must draw a line in such a way that it must leave some points on the right and some point below the line. And we call that the line of best fit. Okay, so now a possible line of best fit we drawn. So this here is a possible line of best fit. So and then looking at this point here, this point is called an outlier. You see, it's very far compared to the rest of the points. So the sales at this month is just different compared to the sales to the rest of the sales. So it's different. So we call this an outlier. It is just too high. It's just too high. Like the 6 months now, on the 6 months, so the sales, the fifth and the sixth, 5, 6, 7 months, the sales is around 50 books, is around 50, 60 books. But now, all of a sudden, on the 6 months, we have a sale that jumped to 100 on the 6 months. So we're saying that is called an outlier. Maybe there is a sort of an organization or a sort of a symposium that is carried out that brings about the book going too high for that particular day. So we say the sales there is called an outlier. So this point is an outlier. So we don't consider it in enjoying our line of best fit. So we don't consider it as enjoying our line of best fit. Okay, right. So that's our line of best fit. Okay. A line can be drawn through 2 points, two of the points with 5 above and 5 below. A line of best fit will not represent data perfectly. So a line of best fit will not actually represent the data perfectly, but it will give you an idea of the trend. So to give you an idea of the trend, so drawing a line of best fit give you an idea of what the trend looks like. So it tells us that the trend was a linear trend, and then it was directly proportional, and that as the month increases, the number of books also increase. So the line of best fit tells us, but it's not actually accurate, because if another person was to draw the same line of best fit, it may not be exactly like this. The person may choose to use this point and use this other point and use this, and it will be a bit different from this. So it's not exactly accurate. So now, how do we deal with such kind of situation whereby we have like different variations of the line of best fit? I say line of best fit is not fixed. It's not something that is fixed, but it's just you connecting 2 points. But the point you must connect must be that the line must go in such a way that it will leave some points above and some points below. So saying if another person is to draw the same line, so it may not be exactly as you have done. So now, how do we deal with this uncertainty? We're going to look at that later. Then in different people, we probably draw slightly different line of best fit, but the trends should be more or less the same in each case. So whatever line of best fit everyone is going to draw, it may not be exactly the same, but the trend should indicate that it's both what a linear and then it's directly proportional. So one of the points is way out compared to the other. This point is called the outlier. So an outlier is that point or is that data that is too high, too big or too small compared to the rest of the data. That's an outlier. Again, an outlier is that data that is too big or too small compared to the rest of the data. So now we're saying that the point they call an outlier, probably what happened during the 6 months was the company had an unusual high sales of book. So there was just an unusual high sales of book for that very single month. So there might have been a conference where the company displayed and sold a lot of books. So what's evident though is that the number of books sold has a linear increase over the 12 months. So what is certain is the number of books increases over the 12 months. Okay, right. The line of best fit drawn in the diagram above is not really accurate since different people will have to draw different line of best fit. What we now demonstrate is the method to determine the actual equation of the line of best fit using the least square method. So now how do we to deal with this variation of different line of best fit? So we use what we call the least square method. We come up with an equation, what we call the least square method. So with the equation, so the equation is a fairly accurate way of determining our line of best fit. Due to the variation that we experience in drawing our line of best fit, so to deal with that, to go around that, is to come with an equation that can fairly always give us the line of best fit in a way that we can use, it can have more reliable value with such an equation. So with that equation, we can extrapolate, we can be able to calculate other values which are not within what we have on the graph. Okay, so we'll be looking at the least square method of calculating an equation can be used for line of best fit. So now the least square method involves, yes, let's see, there's a question here. So usually we don't have 3 outliers, maybe 2. Can we have 3 outliers in a graph? We maybe 2, because outlier implies that is that very 1 or 2 that is very far, too big or too small compared to the rest. So having 3 will mean that is no more an outlier. So having 3 will imply that then is no more an outlier, because that means there are several of such kind of points. There are several of that kind of data. So then, and then we don't, and that will not be considered anymore as an outlier, because now we have got 3 of them. So it won't be referred to anymore as an outlier, because there are like it has its likes. So we will not consider as outlier. So which usually is 1. Usually we have what? 1 outlier, or at most we have 2. 2 in the sense that we have one very high and the other one very low. We can have one on the 2 at the 2 extreme, one very high and another one very low. So we can have 2 outliers, but not usually 3. So having 3 implies that no, it's no more an outlier, but it's not. It's now a pattern now. Okay, I hope that is understood. That is answered. So we will not have 3 outliers in the graph, but maybe 2 at the most, where we have the least one very small compared to the rest, and another one very big compared to the rest. I hope that is understood. Okay, now we say now to be able to find our use our extrapolation, we need. Okay, let's see. Okay, right. Thank you. Right. So now we say now to find the equation of line of best fit, what we call the regression line. So the line of best fit is now called the regression line. So now to find the regression equation, so line of best fit, that is more reliable in this case now, which we want to find is now referred to as the regression line. So the regression line we have what called the regression equation, the equation of regression. Okay, so again, saying generally we have what? Generally, you have line of best fit, but now we are not saying a line of best fit that is more accurate. To have a line of best fit that is more reliable, that's more accurate, that can be more generalized, we're going to refer to it as what? The regression line. And then to get the line, we use the regression equation, the equation of regression. So what's the equation of regression? The equation of regression, you can ask y equals to a plus bx. Y equals to a plus bx, where your a represents your y-intercept and your b represents your gradient. Your b represents your gradient, or your b represents your slope, and your a represents your y, the intercept on the y-axis. The same, remember we have this kind of equation, our linear equation of a linear graph, where we say y equals to mx plus c. So the same way, y equals to mx plus c, here our c is our y-intercept. In this case, our a is our intercept on the y-axis, the y-intercept, and then the slope is the gradient. If the line slopes upwards, then we say it has a positive slope. B will be positive, the value of our B will be positive. And then if it slopes downwards, then we say our B will be negative. So now this is called the equation of regression. And to find the equation of regression, all we need to do is to find the value of our A and our B. We need to find the value of our A and our B, and we can do that only with our calculator. Okay, we do that with our calculator. We do that with our calculator. All right. So use our line of best fit. To find our A and B, we use the calculator to do that. So to find our A and B, we start with our calculator, and then what we do, we start with calculate, press our mode. Press our mode, or your calculator is written in the body, the button that's written mode. So press mode, then 2. Okay, then press 2. When you press 2, then you're going to see a lot of, after pressing mode, then you're going to see a lot of things to be, a lot of equations will be listed out. Then you press the 2 one. The 2 one will show a plus bx. So then you will press the 2 because we want an equation that's written a plus bx. So we press 2. Then after that, after you press 2, then 2 columns will be shown. We'll have 2 columns. So you have the column x and column y. So by column x, you will put your independent variable, your x values. And then on the column y, you enter it. As you press it, so our values on the x, you're going to put it the way it is on your table. The way it is on the table, you're going to put the value the way you have it on the table. Okay. So you put your, we said number of months is your x, so you put this as your x column. So you put 1 equals to point, put 2 equals to 3 equals to 4 equals to, you enter all this on your x column. And then you enter all this other number, your y column, and you enter it on the y, go to the y, press 10 equals to 22 equals to 20 equals to 38 equals to 46 equals to, so like that you punch in all this number. Okay, so after punching all the number, so what next you do? Then you're going to press the AC button. Then you press the AC on the left side toward the bottom of the calculator. There's the button written AC. You press the AC. What I call out accept. You press that button. When you press it, you see the data goes as if the calculator accept the data. So the calculator becomes clear. Then after now, press Shift 1 again. You press Shift and then press 1. And then you press 5, then you're going to see it and what is written regression. Then you press 1 to get the value. So when you press 1 to get the value, you're going to have this as your A. When you press 1, 1 is indicating A. So if you press 1, then the 1 will give you the A, the 1 is sitting next to the A. So if you press 1, then you're going to give you the A value. So in this case, we're going to see a value, this value show up in your calculator. Okay, and then that is your A value, which you can record. You can put down as your A, which you're going to use your equation of regression. And then to get your B, you press a Shift 1 again. Then you press 5 as a regression again. And then you're going to see B. You press 2 for the B. The 2 indicates the B. So with calculator, if you do this, you're going to see that the value for your B, this value will show up in your calculator. It's your B value. So which we now have to now put in your equation. So you're going to have it as y equals to your A value, which is what? Your A value, which is 3158. Then and your B value, you now have to put it. So you have it as y equals to bx plus A. So this is your A value and this is your B value. You have just put here. So this here is called what's your regression equation. So y equals to 6,896,1783,44x plus 5,3159,23567 called the equation of regression. We call the equation of regression. Okay. So now with this equation, it's called the equation of regression and the equation of what? Or the best line of fit. The best line of what's best fit. Okay. So now with this equation, we can do extrapolation. So say you want to find a value, you want to find a value outside, you want to find, remember your y is your number of months, and your x, your y is your number of sales, and your x is your number of months. Your y is the number of sales, your x is your number of months. So if you want to find, for example, how much sales to be made in the 30th month. So you're just going to put your 30 by x, you substitute 30 for your x, and then you punch your calculator, and then you can find your sales for the 30th month. So this is an equation with which you can find the make extrapolation and intrapolation. Okay. Right. So we're saying again here that a very important principle is to understand that the line of best fit always passes through the main point. Now, when you draw the line of best fit, so the best of them all always pass through the midpoint. We say we can have different types of lines of best fit, but the most reliable one, the best one, is that one that passes through the midpoint. Okay, is that one that passes through the midpoint. How do you find the one that passes through the midpoint? Is to find the coordinate of the mean. To find the coordinate of the mean. How do you find the coordinate of the mean? You get your your x values, those values on your x-axis, you find the mean of it. On your x-axis, they are the months, and then you have 1, 2, 3 up to 12, and then you divide it by 12. But you are not going to add on one of the months. One of the months will not be added. Going to have it as 11. Going to have 11 months. So why 11? Because there's an outlier. Remember, there's an outlier. The outlier will not be included in our calculation. So we're going to have we have 11 numbers added divided by 11. So finally, the mean value, the mean coordinate for the x. The x coordinates are the main position. Okay, we find the x coordinate at the main position. You add all your x's, meaning all your data on the x-axis divided by 11. Why 11? Because our outlier is not being used. So this one will give us our x coordinate at the main position. So the same thing you do for the y. Find the y coordinate at the main position. Add all the 11 numbers divided by 11. Get your y coordinate at the main position, and then you can plot it on your graph. So the x coordinate at the main position in 1 decimal place is 50,5, and then the y coordinate at the main position is 50,5. So which is two coordinates? This is the coordinate of our main point. So these two coordinates can be plotted on your graph. So when plotted on the graph, you're going to have it at this point. So any line that passes through this point will be the line of best fit. It will be the most multipliable one. So that is how to determine line of best fit. I do hope you understand. So the outlier is not always included, because when you consider the outlier, then you will have a false mean. The outlier is going to raise your mean, and you're going to have a false mean. So now we talk about the interpolation and extrapolation. In extrapolation, try to find the value of a point that is not within your graph. Okay, the process of estimating the number of books outside the given 12 months is called extrapolation. And then the interpolation is when you're finding a value in between your graph. So in any case, we use our equation of regression. The equation of regression we found, we use our equation, and we can always find what our value is. So this is how far we're going to go into this class. So let's revise, let's consult our textbook, and let's do more examples. Let's practice this we have said, especially with our calculator, to find the equation of regression and the equation of regression and drawing lines of best fit. So here is an example, a takeaway example. The table below represents the distance in meters required by a car to apply brakes and reach a standstill when it's traveling at a given point. So this represents what the distance in meters required by a car to apply brakes and reach a standstill. So this is the speed, and this is the braking distance. So now draw a scatter plot to represent this data. So which one will depend on which one goes on X, which one goes on Y, which one depends on which? So the braking distance will depend on the speed. The braking distance should depend on the speed. So the higher the speed your car is coming, the more it will take for you to brake, when you apply your brake, the more it's going to take for you to stop. The same with your braking distance will depend on your speed. So your braking distance will be your dependent variable, which will be plotted on the Y. Your speed will be independent variable, it will be plotted on the X. Okay, so like that, we draw our scatter plot and then explain whether it's linear, quadratic, or exponential. You see that it's linear, and then determine the equation of regression line. The calculator will determine that. We find the value of our A, we find the value of our B, and then we get the equation of our regression. And then use your regression line to estimate the braking distance at the speed of 150 meters and 130 meters. So we can always substitute this into our equation and find our answer. So let's practice more on this. We'll see tomorrow, and we'll continue from there next class. All right, thank you for attending, and then enjoy the rest of the day. So tomorrow we're looking at correlation and different types of correlation. Okay, thank you for listening, and enjoy the rest of the day.